Today we will look into solving system of equations by elimination. We will add or subtract equations to eliminate a variable. We will first make sure that our equations are lined up. Then we will add or subtract equations to eliminate the variable with a common coefficient. Then we will solve our equation for the remaining variable. Once we find the solution, we will substitute that solution into either of the original equations and solve for the other remaining variable. Here's our first example. It looks like we have the y values are lined up, x values are lined up, and our goal is to find a variable that is almost like positive 2x and negative 2x lined up together, so we can add them side by side to get 0x, which is going to be 0. That's how we will eliminate a variable. In this question, it looks like we do not have a variable that's going to eliminate directly. So we are going to multiply the entire equation by a negative number. Our first equation did not change. Our second equation was negated completely. So we will have negative y is equal to negative x plus 2. Now we have two variables with opposite sign coefficients. And we can add the equations side by side. We will have 0 is equal to 2x plus 6. And subtract 6 from each side. Negative 6 is equal to 2x. Divide each side by 2. X is equal to negative 3. We will put this answer into either of the equations and find the other variable. Y is equal to 3 times negative 3 plus 4. Y is equal to negative 9 plus 4. Y is equal to negative 5. Our solution for the system is x negative 3, y negative 5. We can do a check step on this. To do a check step, we would substitute our solution back into both of the original equations, and both of the equations must satisfy the solution. Here's for the check step for this first equation. Negative 5 is it equal to 3 times negative 3 plus 4. Negative 5 is it equal to negative 9 plus 4. Negative 5 is yes equal to negative 5. That's satisfied. Here's the check step for the second equation. Negative 5 is it equal to negative 3 minus 2. Negative 5 is yes equal to negative 5. Both of the equations satisfied our solution. Here's our second equation. Our goal is to eliminate one of the variables. It looks like the x's will be easy to eliminate, but neither of them is negative. So we're going to make one of them negative, one of them positive, so they can eliminate. We're going to multiply the second equation, entitled by a negative, and our first equation stays the same. Second equation becomes negative x plus y is equal to negative 3. Now I can add the equations side by side. Here's the equal sign. You have x's adding up to 0. They are eliminated. And 4y plus y is equal to 5y. 13 plus negative 3 is 10. Divide each side by 5 to solve for y. Y is equal to 2. We will substitute this value back into one of the original equations. X plus 4 times 2 is equal to 13. From that, we would get x plus 8 is equal to 13. X is equal to 5. Our solution for the system is x5, y2. We can also do the check step like we did on the first example. Please pause your video at this point to solve question number 3 and number 4 on your own. You should have multiplied one of your equations by a negative, and first equation stays the same. Second equation is negated. Add them side by side. Y is equal to 1. Substitute this information in one of the original equations. Our solution would be 8, 1. You can do the check step to confirm. You should have multiplied the entire equation by a negative. Then you would have 3x minus 4y is equal to negative 10. Negative 3x plus 4y is equal to positive 13. Once you add it side by side, the entire left side is going to be equal to 0. The right side will be equal to 3. 0 and 3 is a false statement. Therefore, you would have no solution for the system. Here is our fifth example. It looks like our variables are already lined up, and one is positive, one is negative, and they are ready to be eliminated. We're going to add the equations side by side. I will have 0x plus 0y, which is equal to 0. On the other hand, negative 10 plus 10 is also equal to 0. This is a true statement. When we have a true statement, it means that for any x value and y value we choose, it will give us a true result. Therefore, I can choose infinitely many x and y values as solutions. In this example, our equations are not lined up. First thing we want to do is to line up our equations. I will take our first equation and subtract 2x from each side and rewrite it. Negative 2x plus 4y is equal to negative 8. And the second equation, I'll keep it as is. 5x minus 4y is equal to 20. Right now, both of the equations lined up, we need to determine which one of the variables would be easiest to eliminate. It looks like negative 4y and positive 4y are ready to be eliminated. We will add the equations side by side. 3x is equal to 12. Divide everything, each side of the equation by 3. X is equal to 4. We will substitute this information into any of the original equations. I will have 4y is equal to 2 times 4 minus 8. 4y is equal to 8 minus 8. 4y is equal to 0. Divided everything by 4. Y must be equal to 0. From these two, I get my solution as 4, 0. We can also do the check step by substituting 4 and 0 back into both of the original equations. What do we do if there are no matching coefficients? We would multiply either one or both of the equations to create matching coefficients. In this example, we can multiply the first equation by negative 2. Then we will create negative 2x minus 6y is equal to negative 12. Also, on the second equation, we did not change anything. Negative 2x minus 7y is equal to negative 1. Add them side by side. We have negative 13y is equal to negative 13. Divide everything by negative 13. Y is equal to 1. I'll substitute this information into one of the original equations. X plus 3 times 1 is equal to 6. X plus 3 is equal to 6. X is equal to 3. Our solution would be 3, 1. Please stop your video and try to solve this question on your own. You could multiply the first equation by 4 to create 12x minus 4y is equal to 56. 5x plus 4y is equal to 12. We could add them side by side. We will have 17x is equal to 68. Divide each side by 17. X is equal to 4. We can put that information into one of the original equations. 3 times 4 minus y is equal to 14. 12 minus y is equal to 14. Subtract 12. Negative y is equal to 2. Y must be equal to negative 2. We found both x and y values. Our solution must be 4, negative 2. Here's our next example. On this one, it looks like we do not have already matching coefficients. We're going to have to multiply both of the equations to create matching coefficients. Let's multiply the first equation by 5, and let's multiply the second equation by 2 so that our x values can match. Our first equation will become 10x minus 20y is equal to 90, and second equation would become negative 10x minus 12y is equal to 6. Then we can add them side by side. Negative 32y is equal to 96. Divide everything by negative 32. Y is equal to negative 3. Once we find the y value, we can substitute back into any of the original equations to find the other variable. 2x minus 4 times negative 3 is equal to 18. 2x plus 12 is equal to 18. Subtract 12. 2x is equal to 6. X must be equal to 3. We have found both x and y values, so our solution is x3, y negative 3. Please pause your video to try this question on your own. You might have to decide which one of the variables you want to eliminate. You could have multiplied only the first equation by negative 2. Then you could get negative 6x minus 2y is equal to negative 4. And the second equation would be 6x plus 2y is equal to positive 4. If you add everything side by side, you will have 0 is equal to 0, which is a true statement. So for every x and y value, you will receive a true result. And you can use infinitely many x and y values as solutions. Now please work on question number 5 on your own, and we will check this question on the class. Please solve this question on your own, and we will check your answer in the class. And do not forget to complete your knowledge checks and submit them online.